as soon as I get set up. Okay. Thanks very much, Professor Kleinrock. As he was just saying, I'm one of the many packets that he sent across from UCLA to Stanford. A lot of the speakers this morning talked about what happened here 40 years back, a very momentous historic occasion. I was actually, on a personal note, I was here about 15, 20 years back when the next big revolution was actually happening. So I remember being in the labs of Boulter Hall, firing up my first Mosaic browser, and actually surfing through the entire web in like an hour or so. The web has grown a bit since then, so I'm really excited to be here to talk about the next big wave that is happening in computing. This is exactly why we need to have cloud computing work, because you don't need to have PCs. PCs with these, these interfaces and hard drives, they don't really work. So I'm going to motivate the problem with a few specific use cases to what is actually helping people move away from personal PCs into getting the data into the cloud. So this is a common use case that a lot of you have seen as we engage with more and more teams. We start with a basic Word or text or Excel document. And then you start creating some interesting content, and then I send a version to my colleagues, and they start making some revisions, and they create new versions, and then the next step is to pass it along to back to me to do some merging and to get the content to be coherent. And after that, I send it across to everyone again. But it's kind of lost effort and lost productivity. So we're moving a lot more towards a knowledge economy where pretty much people are collaborating a lot. And wouldn't it be much cooler if there's actually just one copy of that document or spreadsheet or presentation that is in the cloud, and everyone can collaborate with that piece of content interactively? Another use case is that of how I keep changing my smartphones all the time. I buy a new iPhone, I buy a new iPhone 3GS, I have multiple devices, I have my BlackBerry, I have my Android phone. And pretty much when I had to switch between my even basic personal information like contacts, which has to be pretty consistent across every single device, that's another use case for having the content being in one spot in the cloud, where pretty much every device can access it and start using it. And I should be able to manipulate that as I want. If I meet someone over here today, I should be able to add it to my phone and have it automatically synced up to all my devices. So that's another use case. Another common use case is the one we just ran into, which is PCs. So about a week or so back, the hard drive on my Mac died. And then all I had to do was I just had to go to the local Fry's store and just pick up a new PC. And I didn't have to worry about backups, because pretty much all the information that I care about is actually in the cloud. My email, the documents that I work on, all my contact information, all that is in the cloud. In fact, this presentation is actually coming from Google services in the cloud, and I'm just projecting it because the network's a lot faster, thanks to all the last 40 years of work. So where does the word cloud computing come from? So there are many theories on this. So this is one of Google's data centers. You can see the scale of the systems that we're actually building. So that building over there is just a whole bunch of machines. And then you have cooling on top of it. And you can see the cloud just coming out of it. So there are a few such companies that are actually building out these clouds, where there's just a lot of machines, a lot of horsepower of computing just happening in a few utility stations, so to speak, and they power a lot of smoke into the air. So that's one interpretation. The other interpretation that seems less interesting is that PowerPoint used to have this Clippy, which actually had this little cloud thing, and people just started using those to draw the basic architecture diagrams. And so that's the other interpretation of cloud. But I think this is more interesting. So this is not a new idea. This is actually T.J. Watson supposedly said there's a world market for 5 computers. And people have actually, over the last 40 years or so, have actually made a lot of fun of him because saying that, hey, maybe he didn't anticipate the fact that personal computing was going to be a big deal. I would actually argue that he thought even further ahead and realized that the world is going to move much more towards how electricity works, how water and how shipping works. Right? You actually have these, in the beginning of any industry, you typically have a lot of compartmentalization of information as well as smaller players. Over time, as the economies of scale kick in, and you start having these larger entities which can offer utility to a wide audience. So there's some numbers about how electricity sort of took off in over a 20-year period. Most people were producing their own electricity, and within about 20 years, it actually declined. The private production of electricity declined less than 5% of the overall production, and public production through these utility companies actually got up to about 90%. And that happened in the span of 20 years. So I would say that we're actually at that stage right now. So Sun tried this too. Sun and Oracle in the 80s and 90s said the network is the computer. Again, very insightful. So they again wanted to move to a model where you had these companies which actually had their local LANs, and you had a whole bunch of very thin, dumb terminals that were just hooked up into the LANs. It didn't work because again, the information was still compartmentalized even within a singular company, and people still found it a lot more convenient to take their personal device, their hard drive, their floppy disk, or their machine as they walked around and went home and worked. So a couple of things have actually changed since the last few forays into this area. Again, this happened in the late 90s as well when managed service providers came into play. So one big change that has happened just in the last 10 years. This is because of a lot of the investment that happened in networking over the last 40 years, but again, a lot of CapEx that happened in the late 90s, early 2000. The amount of bandwidth, I'm sure a lot of you have seen various versions of these things, where the amount of bandwidth just in the last 10 years has just gone up by a lot in terms of the amount of bandwidth. If you remember just 10 years back, you probably had a 52 kilobit per second modem by which you're accessing content from your home. But now it's actually, on a per capita basis, it's probably 5 megabits per second or a lot more. And the latencies have actually come down as well. So this is just in the last 10 years, 2000 to 2008, in terms of the overall growth. And now, some projections estimate it's about 720-ish terabits per second just in the US alone, which is a pretty phenomenal number to work with. So now people actually can really put all their personal information, personal content, the content they care about on the web, in the cloud, and still be able to access it from wherever they want to. The second big driver, and some of the speakers earlier have actually talked about this, is the growth of smartphones. I don't just care about my PC anymore. I don't just care about my single PC. I actually care about multiple PCs when I'm at work, when I'm at home. And also I want to be able to access my contacts or my documents or even this presentation on my iPhone, on my Android device. So this is by one of the many companies that get paid to estimate how big the smartphone market is. But whether you believe that the number is going to beat PC sales by 2011 or 2012, it doesn't matter. The main point of this is it's going to happen in the next couple of years, that people are going to be using a lot more smartphones to access the content that they care about than ever before. So it's implicit in that data should not be tethered to the machines that you work with. It has to be somewhere else, so you can actually just access it from multiple points. So this is a sort of a rough classification of the different offerings in this space. So this is just two axes that I thought would be interesting to this audience. On the x-axis, we have portability of data. How easily can you move data into a service, and how much can you trust them, and how easily can you take data out? And on the y-axis, you actually have whether the provider is offering a basic virtual machine, or are they offering something higher up in the stack in terms of applications like Gmail or Salesforce.com or examples along those lines. So on one of the leading players in the space in the infrastructure part of the equation, as some of you know, is Amazon in terms of its web services offering. So they have a number of different offerings in terms of elastic cloud computing as well as storage, through which they have made it so easy for any startup to just build and focus on the product that they care about, rather than worrying about buying more machines or working towards scaling up their own infrastructure. One of my friends recently he has a startup, and he was saying that Apple, for whatever reason, decided to feature them in a television ad. So they expected about 10x the normal capacity, because essentially the Apple effect or the slasher effect or whatever, right? So he didn't have to do much more than just take out his credit card and just buy 10x as much capacity for that 1 week period, when he was actually getting a lot more of the traffic. And interestingly, Amazon has the same problem or the same issue from a different side of the equation. They have to over-provision because their 1 week period before Christmas is incredibly crucial for the company, and they had to build towards that. For the rest of the year, the machines are sitting relatively idle in a 20% capacity or even lower in some cases. So Amazon is one of the players in the space. There are many other players in the space as well. This is just a way to sort of highlight the differences between the offerings. Salesforce.com is another example of a very vertical application provider who focuses on the CRM market. I mean, there's nothing special about the CRM market, except that they sort of were one of the leaders in breaking the mindset that we have to do a massive installation of software or clients in a company and actually have to manage it over time. So they sort of broke the model by saying, we're going to do all this hosting for you, we're going to understand your domain, and we're going to make interesting applications that will work across these devices and different computers in the sales space. So they've been expanding into the platform cloud space, allowing other third parties to build in the space as well. Google is a big player in the space. I'm going to mostly talk about Google Apps, which is I'm sure a number of you actually use a lot of these products that we offer. That's really about the application cloud. So what is useful for the user, and what can actually be pushed, what personal information of the user that the user wants to manage in the cloud. And the other key part over here in terms of the portability of data is we fully believe that the user has to have lots of choice in terms of, if they don't like our products at some point in time, because we do a terrible job with X, Y, and Z, they should be able to move from one service to another. And this is how the industry is heading. We're sort of helping the industry move along to get away from lock-in, which is not what the users actually want to get into. And data liberation is one of those themes that you'll hear a lot about in the next few years. So I want to focus a little bit on Google, now that I've given a broad picture of how the market is shaping up. So early on, this is sort of this is evolution of Google hardware. In '97, it's a couple of machines beneath Larry and Sergey's desk in Stanford. It had Lego blocks. I'm sure you've seen these pictures in the past. And over time, we've been getting more and more sophisticated about a whole bunch of issues in terms of exactly how do we customize the hardware that we buy based on commodity parts to make it cheap, efficient, as well as reliable. And how do we build out our stack? And this is the stack that powers your Google.com searches, as well as our general cloud computing offering. How do we make it fault-tolerant, reliable, and scalable? Right? These are the core problems that we've all studied in distributed computing over the last several years. And we have a lot of machines. So we've been investing a lot in trying to get exactly the right setups for moving data around. How do we minimize power? And this is ongoing research. As the scale keeps growing every so often, these problems get even more and more challenging. So we've been dealing with large scale for a long time. And on the search side, it's a billion plus searches. I'm sure a lot of you use our search product, where you just go and search and find things on the web. And the thing that we are really proud about is how we can use our massive computational resources to partition problems so that we can make it very, very fast for the user. The amount of data on the other end has been growing dramatically. The web I could surf in an hour is actually a lot bigger than that. It'll take me like 10 lifetimes to just go through every single page, or even longer. On the infrastructure side, we don't actually say how many machines we have, but there are these well-paid research agencies like Gartner who predict how many machines we have. So this is, per them, we actually have 3 million plus computers. we index the web on a regular basis to actually make it useful and more real-time towards what you actually need. On the application side, this is the consumer part of it that a number of speakers actually referred to earlier. Just Google Calendar, where you actually manage your events in a given day in the cloud, sends out more than 1 million messages just per day, just in terms of the actual scale. There are billions of instant messages floating around within our network, and some of the other speakers referred to the amount of content that we have on YouTube. There's like 20 plus hours just being loaded every single minute into YouTube, which is a pretty phenomenal number. The number of photographs that we actually host is just keeps growing. The amount of data that people are pushing into the cloud because they don't want to deal with having it on their own machine and dealing with the backups and the networking within your house. All those things are just increasingly moving there. So we are, in terms of where we're heading, so the cloud apps that we offer right now are primarily about your personal information management. So we want to certainly make them a lot simpler, and we want to keep adding more and more useful personal apps towards people. And it's important from our perspective in a couple of areas that we keep offering our platform as well to third parties. So startups can do a lot more with the platform that we have and make it extensible for third-party developers to build against our platform as well. I'm going to skip the on-premise part of it, which is our offerings within enterprises. But let me talk about access. So access is kind of a big deal. Over the last few years, when Netscape and IE were having an interesting battle about the browser wars, there's a lot of innovation happening in terms of the web standards actually moved a lot further when there was a lot of competition. And then it kind of declined because IE sort of took market share. And the web platform, the browser technologies just kind of stabilized and didn't move forward. And then Firefox and Safari have been pushing that battle forward. And recently Chrome, which is actually one of the fastest browsers out there, the reason why we entered the space is as a collection of different companies, we can actually get to a point where we can move the standards forward again and actually build much more richer experiences in a browser. Everyone understands the advantages of having a browser, having not to worry about an installation, maintaining the actual software, and having that all being, you can get it from an internet kiosk or your favorite smartphone. So we wanted to keep pushing the browser platform forward as well as the mobile platform forward as well. So this is the reason we care deeply about access of our customers to move the industry forward in this area. So in terms of, in summary, the main principles of Google's cloud are we care about, the reason why we think people are moving into the cloud is for collaboration. I want to be able to create my own contacts. I want to be able to share it with my wife. I want to be able to see when my friend's contact information changes. All that is just very natural to happen in the cloud rather than actually having multiple versions of data. So personal information management, collaboration go hand in hand. Innovation, this is true for pretty much any cloud offering that you can think about. Whenever you build client software, a lot of you know that you got to worry about the underlying platform. You got to worry about how fast you can iterate on software. It takes like a number of years to ship a new OS or new applications. The beautiful part about having applications in the cloud is that the server-side pushes just keep happening. You can keep experimenting a lot with the usability, with the performance, with any information you want to extract. And that is just so much easier to do in the cloud. So it's easy and for developers to try out new ideas and get the most innovative, the latest sort of idea in the hands of the users of these products immediately. The third part I mentioned about data liberation. This is a core component of what we care about. We want to make sure that there's no lock-in whatsoever. We are trying to push the web forward in terms of promoting standards that will allow other third parties to be able to take data out and put data back in. So for example, all the Google Docs, including the editing platform that I mentioned, you can just zip it all up and just move it if our products are not interesting anymore. So that's kind of how we think about it. A couple of issues around trust. This is an important attribute for pretty much any cloud offering. People trust even now, they still trust their favorite computer, and this is going to change over time. But still, you're never sure. When I put stuff into a cloud, will that company go out of business? Will that data be there when I actually want to access it? I don't understand what their backup standards are. So this is one of those things that the industry has to get a lot better about in terms of the common service level agreements and increasing trust by going after by making some of this data transparent, saying that we don't lose data and so on. And there's still a lot of work to happen in this space in terms of how visible a lot of these companies have to be. Availability is another big one, and this is another interesting area of discussion as well, because what if the cloud is down? And what if my network is down? And increasingly, pretty much, if you look at the numbers, pretty much all the cloud offerings are operating at the 99.9% reliability in terms of being able to giving content to people, which actually you would argue is actually better than your laptop when you start thinking about how you lose it or your hard drive dies. So this is another area where we have to be a lot more transparent about how our different offerings are. And also, finally, I can't stress this point enough. Client software is still a lot faster on machines because it just runs against a native CPU. And browsers are effectively a virtual machine. So it's really important for the web and all the applications that we want to develop in the future, whether it's your favorite music player or whether it's your collaboration suite, to get to a point where the standards support a lot more functionality in terms of actions against the underlying kernel to be fast, to be offline, to be increasingly reliable. So this is a lot of areas are going to be, there's going to be a lot of interesting things that are going to be happening in this space over the next few years. Let me finally leave with one thought. So because of the two main driving forces about the amount of bandwidth through which people have access to the cloud, as well as the proliferation of devices, we've gotten to the point where we aren't asking any more as to if the cloud is going to be happening. It's more about when the cloud is happening. And a lot of us believe it's happening right now. More and more businesses are actually switching to cloud-based applications. More and more startups are building against this model of having computation in the cloud and storage in the cloud. And so I think we are the beginning of the next big revolution. Thank you.